Hey guys, welcome back to the next video. In this video, we are going to talk about what is microservices. Microservices, before we get to the design architecture of microservices, let's just first understand what is microservices. Now, when you want to talk about microservices, you need to be aware of there is another alternative over here which is currently being used by major of the service companies called monolithic services. Monolithic services or monolithic applications are nothing but opposite to microservices. So microservices in architecture is an approach where a single application is composed of many loosely coupled and independently deployable smaller services. Which means it explains a lot about monolithic applications. So that's a single application which is not loosely coupled and it is not deployable as a smaller service. So it's a big service comprises of all your whatever your application does. It comprises of everything and it's getting deployed to an application server JVM, which makes it really heavy and very slow. When it's heavy, it becomes slow. So that's where the microservices here is to offer you some kind of a remedy for the slowness by dividing it into multiple loosely coupled application, which also has a communication mechanism, which we will talk on the next slide. The next slide talks about microservices typically have their own stack, which is inclusive of a database and data module, or organized by business capability with the line separating service often referred as bounded context. Let's just understand about microservices. So this is what microservices is. So it's going to have its own module, as in like it's going to have its own environment. So each microservices can have its own DevOps pipelines. It can scale individually and have its own database where it owns a data module. So that's typically what microservices is. Now, what is not a microservice? I mean, what is a monolithic architecture or service-oriented architecture? There are two different types of architectures here we compare with. Very simple. Microservices can also be understood by what they are not. So that's what we compared it earlier about what is not a microservice. And there are two comparisons drawn most frequently with microservice architecture or monolithic architecture and service-oriented architecture. So in a nutshell, what is not a microservice is a large, tightly coupled application. So when I talk about large, tightly coupled application, the difference between microservice and monolithic architecture is that microservice composes a single application from a smaller, loosely coupled service as opposed to my monolithic approach of a large, tightly coupled application. The difference between microservice and SOA can be a little less clear. While technical contracts can be drawn between microservice and SOA, especially around the role where the enterprise service bus comes in. It's easier to consider the differences as out of one on the scope. So SOA was on an enterprise-wide effort to standardize the way the service talks to integrate with each other, whereas microservices architecture is application specific. The biggest difference what I find in these two approaches is how they are deployed. For many years, applications were packaged in a monolithic fashion, and it is the team of developers constructed one large application. They did everything for a business need or the application need. After the application was built, it was deployed multiple times across the farm of application servers. In contrast with microservice architecture style, developers independently build a package or smaller applications that can each implement one part of the whole application. That's what the entire a microservice it is not. It is not building one big cluster application, but it is to build a smaller application. That's the summary I want to tell you about this particular slide. So microservices works on this principle. So that's what we are going to talk about. The first principle is when you deploy microservice of application, the first thing is like one job. Each microservice must be optimized for a single function. Each service is a smaller and a simpler to write, manage, and maintain. That's the first principle. I'm sorry, I skipped to the next one. Separate process. So communication between microservices must be conducted through API and message broker. All communications from the microservice to another service must be through a service API, or it must be explicitly having a communication pattern. The next one is about execution scope. Although microservice can expose themselves through an API, the focus is not on interface, but on running components. The next one is going to be about CI/CD. Each microservices can be continuously integrated and continuously delivered. When you build a larger application which is composed of many services, you soon realize that the different services evolve at a different rate. If each service are unique and continuously integrated and continuously deliver, having a separate pipeline, the services can proceed at its own pace, and you will see a much different rate of evolution in terms of having these applications running separately. In monolithic approach, the different aspects of systems are released at a speed of the slowest moving part of the system, because it is tightly coupled and you may need to have a lot of knowledge around the applications which the developers are developing. In terms of the resilience or resiliency this time, you may apply high availability and clustering decisions to each microservices. When you build a large system, another realization that you have is that when it comes to clustering, one size does not fit all. The monolithic approach of scaling all the services in the shared resources and monopolized services might be neglected. Even worse, a large system, when you deploy it, and you don't need to scale to the maximum number of servers to conserve resources. Other services requiring scaling up to a large number. So there is a lot of disadvantage towards resilience in terms of working with monolithic application. As the bigger the application becomes, you kind of the cluster kind of struggles to deliver the application, and it needs to load it even if it's going to be accessed by the users, or it doesn't need to be accessed by the users, but still it has to keep it loaded and ready for the application users to start working on it. So the resilience also is a major issue towards monolithic application. But when you compare with the microservices, as it's going to work individually, it's going to be much easier for these resilience in place of high availability and clustering decisions on the microservices, or when you're hosting on microservices. All right, so let's get to the next one, which talks about the benefits of microservices. Like, while we are discussing about the microservices resolves around architecture definition and characteristics, the value can be understood through simple business and organization benefits. The first one is about the code can be updated more easily. Each microservice is built and aligned around a business function to reduce the complexity of the application change management process. Because each service is individually changed, tested, and deployed without affecting other services, time to market is accelerated. In terms of the other benefits, is improved by application quality. Microservice architecture leads itself to a test-driven deployment. As component can be tested in isolation and combined with a full or virtualized set of microservices. This approach results in an overall improvement in application quality. The next one we are going to talk about is the components can be scaled individually of another by reducing the waste and the cost associated with having a scale entire application. So in this way, you can actually look at those components which is majorly used and then scale those components rather than scaling everything which is available for you to scale. So this will be useful in terms of reducing the resources, reducing the bill payment on your cloud if you're hosting or your application on your cloud. In terms of efficiency, teams becomes more efficient because microservices are designed to act independently. They are naturally consistent with agile principles that promotes end-to-end team ownership. Teams that develop microservices can make technology decisions that are right for the job. They can use different stacks for different components. They can experiment with new technologies, libraries, languages, and frameworks, which yields faster innovation cycle. Microservices are likely to be popular with executives, project leaders, and developers because they are better reflect the way many business leaders want their business structures and run their teams and development processes. To put another way, microservices are an architectural model that better facilitates a desired operation model. So these are the benefits of microservices, as I told you before. To summarize, it is to simplify deployment, it is to improve application quality, it is to ease the scalability for your application to reduce the overload of your application, and it is to make your teams effectively work together in terms of delivering their individual goals rather than working on a big chunk of application which they should have understanding about every component of the application. So that's pretty much covers what is microservices, and then probably in the next video we will be seeing more about the microservice architecture on the next video. Thanks again for watching this one. I'll see you on the next one.